Thanks, Ian, for the kind introduction. So I would like to thank Nigel for inviting me to speak, and thanks also to Zara and Marina for the excellent organization of this event. It is a pleasure to be with the H2FC SuperGen community again. So I remember that when I was a PhD student, Dan Brett invited me to give a presentation at a couple of hub events in Loughborough. And that was when I first met Nigel, and I saw what everyone was doing in the hub, and it inspired me and sparked my passion for various hydrogen technologies. When I obtained my PhD, I had an opportunity to work in the hub with Nilay and Nigel. So I would like to start by briefly summarizing my research, which is neatly captured by this image, which was featured in a Royal Society of Chemistry journal. So my research is about developing large optimization models of value chains to supply products and services in the most efficient and sustainable manner. So a value chain is a network of processes or activities required to obtain raw materials and primary resources and convert them into useful products and services along with logistics such as distribution, transportation, storage, and inventory management. So along the value chains, there are many interdependent decisions involved. So for example, for green hydrogen value chains, such decisions include how many wind turbines and solar farms to build, of each type and where to install electrolyzers, how to transport electricity and or hydrogen, how much electricity grid reinforcement is needed, and how much hydrogen pipeline network needs to be built. So where to store the hydrogen and how to manage its inventory and what services to use the hydrogen for: heat, transport, power, industry, and so on. So there are so many different combinations of these decisions. So I am developing mathematical models and computer algorithms to automatically identify the best sets of combinations, which will be useful in making decisions, for example, around land use, location of processing facilities, the levels of production, and the most effective logistics and inventory management policies. So many hydrogen technologies are ready for deployment, but the challenge we're facing right now is establishing strong and robust value chains for hydrogen. Modeling and optimization are effective tools to design and explore various hydrogen value chains. So my research group have developed a very comprehensive hydrogen value chain optimization model with line pack, hydrogen injection into gas grids, heat pumps, carbon capture storage and utilization technologies, underground storage, such as salt caverns, depleted oil and gas fields, negative emission technologies, and so on. So here are some recent publications of my research group at University of Bath. So these selected publications are all about whole system optimization, and we looked at the role of interseasonal hydrogen storage. We compared hydrogen against other energy carriers such as electricity, syngas, and so on. We also looked at the role of power to gas, hydrogen injection into gas grids, and line packs. So the role of hydrogen and carbon capture, storage, and utilization. And in this last paper in the list, we evaluated the effectiveness of various policy instruments for hydrogen in achieving net zero by 2050. So my group has more publications for hydrogen for heat, power to hydrogen to X, and so on my personal webpage at the University of Bath. So as Ian already mentioned in my introduction, I'm one of the 15 members of the science expert group of the UK Government Department for Business, Energy and Industrial Strategy, BASE, providing independent scientific and technical support to the BASE Chief Scientific Advisor, Professor Paul Monks. So we are looking at whole systems approach to determine pathways to net zero, and the government's 10-point plan for a green industrial revolution recognizes the role that hydrogen will play. So a few of the key points that we discuss in this group are that net zero should be sustainable, resilient, and measurable. All sectors of the economy should decarbonize, and one of the challenges is how to do so in an equitable manner. So the transition to net zero offers some opportunities to gain economic advantage for the UK, and we will have to identify where these lie and promote them. So finally, I will also be leading a task for the International Energy Agency Hydrogen Technology Collaboration Program, which will be designated as Task 42. So this task is entitled Hydrogen Value Chains for Decarbonizing Hard-to-Abate Sectors such as steel, cement, petrochemicals, especially plastics, fertilizers such as ammonia and aluminium. So these are responsible for 22% of global CO2 emissions, and we will not be able to achieve our net zero targets if we do not decarbonize these sectors. So in terms of using hydrogen, we need to prioritize the hard to abate sectors because this is where we can achieve the largest CO2 abatements per unit cost. So for example, using 1 ton of green hydrogen to produce steel will abate 26 tons of CO2, whereas using the same 1 ton of green hydrogen for mobility only abates 6 or 7 tons of CO2, and it's lower for other sectors. So this is where we can get the biggest impact for the money spent. So also one can argue that other sectors have options. They have other options for decarbonization. So for example, heat pumps for the heating sector and electric vehicles for mobility. However, it is very challenging to electrify completely some industries. So for example, in steel making, hydrogen direct reduction is one of the promising alternatives for decarbonization. Similarly, the cement industry, which uses large amounts of heat, is less suitable for electric heating than using hydrogen. So my next point is that to start and grow the hydrogen market, we need large and reliable demands. So currently, there is very little take-up of hydrogen vehicles and possibly even less for hydrogen heating in homes. Whereas switching industries to hydrogen will very quickly create a large demand for green hydrogen, which will encourage many producers to enter the market. So this would then make it easy for green hydrogen to trickle down to other sectors. But there are challenges that we need to overcome for this to happen. So the first challenge is to do with time. So these energy intensive industries have long investment cycles. And we may think that 2050 is a long way away, but not so for these industries. So for example, blast furnaces for steel making and other major equipment items have very long lifetimes. So if they need to be replaced now, then we want them to be replaced with net zero technologies, or they will be locked into the conventional fossil fuel technologies. It is crucial to act now. Then there is the issue of, carbon leakage. So steel is traded globally and the profit margins are not very large. So the profitability is very sensitive to electricity prices and policies. So for example, CO2 prices. So it is an existential challenge for these industries. So it's not a matter of thriving or not, but one of survival. So we have to be careful in setting policy so that we don't kill off our industries here and force the production to move to other countries with less stringent rules on emissions. So this is known as carbon leakage. So another challenge is capacity. If we are going to decarbonize hard to abate sectors with green hydrogen, then we will need large amounts of renewable electricity. So we will need to build more wind turbines and solar farms, and we will need higher electrolyzer capacities. So the current maximum electrolyzer capacity is around 10 to 20 megawatts. So we need to do something about this. So if any of you here is interested in contributing to this new task on hydrogen value chains to decarbonize hard to abate sectors, then please get in touch with me. So we will take a holistic approach, including taxonomies, technological options and pathways, opportunities and challenges, markets and regulations, and other aspects of the whole value chain. And we welcome participation from experts from all disciplines related to this. So thank you very much. That's all from me, and I'll hand you back to Ian.